Hey y'all, Mr. Austin here coming at you the day before, so 11:15. But today we are talking about 11/16/2020, and we are talking about this objective here that says I can have a better grasp of multiplication strategies by connecting the distributive property to the area model. So it's a Monday. Uh, if you were me, you had a fun weekend where you got to spend some time with the family. You got to do a bunch of different other things. So we might need a little refresher on what some of these words are. So, teacher, we're going to pause the video and we're going to talk about everything we know. We're going to do a brain dump about the multiplication strategies that we know, specifically the standard algorithm and the area model, and this vocabulary of distributive properties. So go ahead and pause the video and have maybe a 5-minute brain dump on area model, standard algorithm, and the distributive property. What do students remember? All right, hopefully you had a fantastic discussion with your teachers and with your fellow classmates. So just a brief reminder, I'm not going to show you how these work because we've done a lot of work with them. But remember, the area model is when we have a rectangle and we use it to understand the place value of things while we're multiplying and finding the area of these partial products to find the area of the whole, which then tells us the product of our multiplication problem. Standard algorithm, remember, I always think of it as standard, I'll abbreviate that, standard algorithm starts with just like the word stacked does. So when we see expressions in standard algorithm, we see them as stacked algorithms, okay? Now, what we need to understand, and today we're specifically going to be talking about the area model. You'll be practicing the standard algorithm to check your work in the problem set and the guided practice with your teacher, and I believe on your exit ticket. But our main concept today is going to come best to you visually by looking at an area model, okay? So I'm going to write an expression up here, and remember, expressions tell us something, right? Expressions tell us things like here we have a expression that tells us that I have a unit of 351 525 times, or I have a unit of 525 351 times. Remember, in multiplication, things are commutative, which means they can move around. And you might be looking at this and thinking, Mr. Austin, we did not do 3-digit by 3-digit multiplication last week. I can't do that. No, sir. No way. Nuh-uh. Not doing it. Guess what, friends? You can do it because you can use an area model and you can use standard algorithm. Let me show you. Just like with the area model last week, we just have to think about what are these parts, right? Here, we see that we have 351. 3 is in our hundreds place, which tells if we have 3 hundreds, which is the same thing as 300. Then we have 5 in the tens place, which is the same thing as 50, and 1 in the ones. Up here we got 5 in the hundreds, which is 500, 2 in the tens, which is 20, and 5 in the ones, which is 5. Now, because we have 1, 2, 3 place values, how many sections on our area model are we going to need on the side and on the top? I hope you said 3 because we have 3 digits for each number. So I'm going to draw my rectangle. All right, I'm looking at this. 525 is my larger number, so I'm going to put it up at the top. You all know this. This is what we did last week, right? This is what we spent the end of last week doing. Now I have 351. So I'm going to write 300 plus 50 plus 1. All right. Draw these over and down. Okay. All right. Now, last week I also wrote them on this side and this side, but I think we can skip that step this week if you're comfortable with it. If you still want to write down each one, that's cool. That's fine by me, but I'm going to skip it just for efficiency this week, okay? So now, let's think about this. Let's get to the bottom of our objective, which is thinking about the distributive property. If you remember, when we talked about the distributive property, we were talking about expressions that might have looked like this. We might have had 8 times 3 plus 12, right? And from order of operations, we know that this parentheses tells us that 3 plus 12 cannot be broken apart. It's one unit. It has to stay together forever and ever. So we just figure that out as 15, right? What we could do is we could also, nope, I'm not going to say that. This is 15. This is 15. And what we're going to do is we're going to distribute the value of this 8 over to 15, okay? We're going to distribute the value of this 8 over to 15. So now we have 8 times 15. Let's see, 8 times 10 is 80 plus 8 plus 5, which is 40. 80 plus 40 is 120. So this is going to equal 120, okay? What I was starting to say as well, friends, and I can just show you real quick, is that when we use the distributive property, we can also, oops, that needs to be a plus sign. We can also distribute the value of this 8 to each part and then add them together, and we'll get the same thing. So here this would be 8 times 3 is 24, plus 8 times 12, 80 plus 16, 96. Okay, add those two things together and you get 120. Okay, so we're distributing the value of that 8 across the expression, which is the same exact thing that we are doing when we're using an area model. So let's come back to this. Okay, so in this first row, excuse me, what we're doing is we're distributing the value of this 300 to 500, 20, and 5, right? So we're going to distribute the value of 300 across our number 525, and we're going to get, let's see, we can use the associative property, numbers with numbers, words with words. So I have 3 times 5, which is 15. And each of them were multiplied by 100. 100 times 100 would be 10,000. So I need 4 zeros. All right, to give me 150,000. Then we're going to distribute this 300 to our 20. 2 times 3 is 6. 100 times 10 is 1,000. 1,000 times 6 is 6,000. Then we have 300 times 5. 5 times 3 is 15. Times 1 times 100 is 100. 15 times 100 is 1,500. Great. So we've distributed the 300 across our unit of 525. Now we need to distribute the 50. Okay, same deal. Numbers with numbers, words with words, using the associative property. 5 times 5 was 25. Then we had times 10 times 100. 10 times 100 is 1,000. 1,000 times 25 is 25,000. Next, we have 50 times 20. 5 times 2 is 10. Then we had times 10 times 10, which is 100. 10 times 100 is 1,000. Next, we have 50 times 5. 5 times 5 is 25. Times 1 times 10 is 10. 25 times 10 is 250. And then next, we are going to distribute the value of this 1 across 525. Now, 1 times anything is going to be the number that's being multiplied by 1. So 1 times 500 is 500. 1 times 20 is 20. And 1 times 5 is 5. All right, now we're going to add all those values up, and we're going to get a product. All right, now Mr. Austin is doing a quick evaluation of what numbers are largest and which ones are smallest, and he's putting them in order from greatest to least. By all means, if you would like to spend the time doing that, go for it. It's how my brain best organizes it, but you don't have to go from greatest to least. The only thing that matters is that you get your place value lined up. So your ones with your ones, your tens with your tens, your hundreds with your hundreds, and so on and so forth. Okay. But this just organizes in my brain better, so that's how I wrote it out. All right, looking at our ones place, we have 0, 0, 0, 0, 0, 0, 0, 0, 5. So adding all those digits together, we're going to get 5. Here we have a bunch of zeros, then 5 plus 2. 5 plus 2 is 7. It's in the tens place, so we're going to say we have 7 tens. Next, we're looking at our hundreds place. We have a whole bunch of zeros, then a 5, and a 2. So that's going to be 12. So if I have 12 hundreds, that really means that I have 2 hundreds and 1,000, because I had 10 hundreds, right? I can regroup them, move them over to the thousands. 10 hundreds is 1,000. So I just put it over in the thousands place. Now here I have 1 plus 5 plus 6 plus 1 plus 1. Well, let's see. I have 6 plus 6 is 12, 13, 14. So that means I have 4 thousands. I'm going to take all the leftover tens, bundle them up, move them over to the 10,000s, making 1 10,000. Next, I have 1, 6, 8 10,000s, and 1 100,000. So our product is 184,275. Now, let's check this with standard algorithm. All right, y'all. This computer is praying for my downfall because this is now the second time I've recorded this clip. So I was talking about how we have 525 times 351, right? And just like in our area model, we are going to distribute the value of each of these numbers across 525, right? And we're not going to take the time to work out standard algorithm. You can do that with your teacher in the guided practice. But what I essentially want you to do is see the connection that here in our ones place over here, we multiplied it times 500 times 20 and times 5. And here we're doing the same thing. We multiplied this one place times 5 times 20 and 500. Then you'll multiply this 50 right here, just like you did over here. You're going to multiply this 50 times 5 times 20 and 500, just like you did over here. 5, 20, and 500. All right. So let's check this learning strategy. It says, I can have a better grasp of multiplication strategies by connecting the distributive property to the area model, which then you can connect to the standard algorithm. I hope that this video turns out well. It was quite a booger to record. You have some amazing teachers helping you out, so hopefully they can fill in any gaps. If I've missed anything in the editing, go and be brilliant, my friends. I will see you tomorrow. Goodbye.